Hello, this is a guide of how to set up FreeCAD with CfdOF and SPH, but this time OpenFOAM will be running on WSL, which is a Linux running inside of Windows. The main reason for that is that OpenFOAM is mainly written for Linux at this point, and the Linux versions have more features. For example, if you want to use any of the big solvers, they're unavailable in the Windows only version. So that's why I'm going to show it this way. Also, the good thing about installing things in this Linux version is that if you ever want to just get rid of it because you broke something, you can just wipe it, install it with one command, and it will be working again. So it's quite convenient. So to install FreeCAD, you just want to Google FreeCAD, click on the first thing. There is a download button here. Install the first installer from Windows, press on it, download it. Already did it. So after you install it, you want to go to FreeCAD and open this administrator. It will open. You'll get a first show saying light mode, dark mode, and the controls. I like Blender controls, but it doesn't really matter. Press OK. Now you want to go into Tools, Add-on Manager. Wait for a second for it to load. And now you want to search CfdOF. This one, the green one. Now I already have it installed, but you press install. You wait probably about 2 minutes and then you close it. This will ask you to restart now or restart later. Press restart later and manually close it because we will need admin again. Open this as admin again. And now make sure that it's working. We go into edit, preferences. Give it a second. And now there should be this window. So now we see that there are two fields. This is the first important one. This is the second one. This is where Ubuntu will live. Where OpenFOAM will live. And this is where ParaView, which is used for visualization, will live. While we're at it, press this append document name. So this helps you so the directories don't override each other. Okay, we can close this for now. And close this for now. Now we want to install ParaView. So we Google ParaView. We click on it. We click on the download button somewhere here. Wait, where is it? Where is it? This download here. And then we want to see the installer, which is the .msi, and then we want the MPI version. MPI is the multi-threading version, so it's the better for bigger models, effectively. We download the MSI, just like I did, and click on it. Give it a second to install. Press next, agree, press next, install it, install it. It might also install MPI while it's installing it, so just press OK a couple times. MPI is the thing that does multi-threading on Windows. Well, it's not exactly multi-threading, but it splits the workload between the cores. And for reference and for simulation speeds and just in general what I'm running on, this is my PC. You can press Ctrl-Shift-Escape to open Task Manager. And in performance, you can see that's the PC I have. Just for other settings that will change later. So now it's finished. Great. So now we can open ParaView 6.1.1. Press allow. Oh, it's opening. You might get a field sort of like opening for the first time. You press a tick box here so it doesn't show again. And now it's running 6.1.1. Now we want to find this ParaView wherever it's installed. I think it installs in C, and then I think program files, ParaView, yeah, ParaView 6.1, and then bin, and then there's the executable. We can sort by file type actually, and there's this application executable. So we just copy path as, and then we open FreeCAD. Go into Edit, Preferences, CfdOF, and we paste it here. But without a string. We paste it here. And press Apply, and press OK. And now we can launch it through FreeCAD. Now how to install the Windows subsystem for Linux. It's quite an easy guide, to be honest. It looks a bit weird if you're not used to command line tools, but there's nothing crazy going on. And if you don't trust any of my commands, feel free to throw them into ChatGPT, Gemini, Claude, and it will tell you exactly what the commands do. But in general, you open PowerShell as administrator. You first want to install everything. So you'll run this command. I already did it and it's working, so I won't run it, but it will finish. And then you'll want to restart your Windows PC because some things set it up. If this command fails, there is a manual way of doing it, which I'll leave in the description. But basically, you have to go into settings and checkmark some things. Then after it's done, you want to copy with Control-C and then paste with right-click. You want to set your version to 2. You want to update everything. In my case, it's updated. After it's updated, you want to turn it off. So basically restart it for the updates to go through. This turn it off. Now you want to see the available distributions of Linux, which is basically versions that you can download. You see a list. In general, I would recommend Ubuntu because it's simple and a lot of people use it. I'll be also using it. Now you want to install Ubuntu 24, which is with this command. I don't copy it. Okay. And I'll be installing 26 because I already have 24 set up, so I don't want to break everything. But you'll press 24, and then this is 24 from the list. And press next, press enter. After it's done, after about 10 minutes, it will ask you for your username. In my case, the default one will be something like this maybe. So leave it in, press enter, and it will ask you for your password twice. So put in something easy so you don't forget about it, like 1234, and then 1234 again for confirmation. Great. You have successfully installed Linux. Now, a tiny detail. The Linux version has a sort of artificial RAM limitation. And to increase it, we need to edit a small file. So you can either run this command or you can do it manually. I can do it manually for a change. We want to go to C, users, FILSDC, which is me. And then you want to find the wslconfig file, which is a small file here. Open it in Notepad and paste how much RAM you want to give it to me. I have 32, so I can give 24 to the simulations. If the file is not here, just make this file, just create new and then name it the same way and put this thing in. Now, just in case you want to go PowerShell again and do the shutdown command, you can press the up arrow to get the previous commands. And shut it down just in case. Perfect. Now we want to go into Windows search and search Ubuntu 24. I'll be launching 26, but it will be exactly the same. So you want to launch it with enter. It's turning on. Now it's on. Now I have a long command to install everything. Again, if you don't trust my command, you can Google what each part of it does, but essentially it just installs everything and builds it for you. The first two things: update the system. These are all the tools for installing. This is OpenFOAM. This is OpenFOAM version. This is the CF mesh for CfdOF and HISA. And this should take probably, I don't know, 10-15 minutes, maybe half an hour tops. And it will also ask you for your sudo password, which is the 1234 you said before. Great. So I did it before. So I'm not going to wait for it anymore. But after that, you press ls. This tells you all the files. And now you can go into check what's inside of OpenFOAM. You press CD for change directory, and then OpenFOAM, and then press tab once. Press it, press ls. You can see that this is the OpenFOAM version. And there are files inside of it. So now we want to go into FreeCAD again. Probably better as administrator, but I don't think it matters at this point. And we have to tell FreeCAD where this thing is. So in general, if you want to find it on a Linux, on a Windows PC, you go this PC, you click on this Linux icon. In your case, it will be 24, but mine 26. And these are a lot of folders, but these are system folders. We only care about home over here. Home here. This is user. And the dots are hidden, but all the folders are the same as we saw here. So OpenFOAM, CFmesh, CFmesh, OpenFOAM, CFmesh, and CF here. So this is the same place. We're interested in this folder, so we go into here, we press properties, and then we copy this whole thing. Oh, sorry, we click on this folder and then properties and then copy this whole thing, so we get the folder. We copy it here, and we go into FreeCAD, edit, properties, CfdOF, and we paste it into here. In my case, I'm pasting in 26 instead of 24, but it's exact same. Okay, we press it into here, right? And then we scroll down and then press around dependency checker. Oh, could not find. Oh, okay. Then in that case, you need to do what I had here before, which is, I don't know why it needs to be done this way, but you need, this will probably be the same. This will be 24, and this will be the exact same for you. So you press this different thing. I don't know why it's like that, but matter. And now run dependency checker, and everything will work. Yeah, see, everything is good. Everything's good. And everything's working. Great. And it's running through this Linux thing. So great. So press OK. So in theory, some of the syntax has changed in the new OpenFOAM versions, which are all done here. So some things in theory might not exactly work, but I have not stumbled upon it yet, so I think it's fine. Just to model a simple case, we want to make a new document, save it. Even desktop is fine. YouTube test. We want to make a, go into part. Let's make a pipe. Why not? Let's make a pipe. Okay. How tall is it? 10 millimeters. Great. Save it. We want to go into CfdOF here and add the analysis container. Expand it. We want to do, oh, we want to move this here, I think. Yeah, okay, good. Tasks, we want to give it, why not steady, can be okay. Laminar, yeah, it can be laminar, why not? Model, fluid properties, we want to make water. Now we want to press on the cylinder, we want to mesh it. So it was 10 millimeters, so give it maybe 1 millimeter, maybe like 1 millimeter will be big enough. Press right mesh. Press run measure. Oh, and in here, right click on here, and then there is a console here somewhere. Oh, Python console. No, whoops, sorry. Report view. And in here you get everything what's happening. Now we can either load surface mesh here. This is a very bad mesh, but will be okay. Or we can click ParaView. And it will open our model inside of ParaView. Give it a second, and yeah, we can see it. Perfect. Now this will not make good results, but it doesn't matter. We clear mesh. Clear mesh. Okay. Quickly, we want to say top will be the inlet from here. Fluid boundary inlet. That might be a bit bigger. Add. And let's give it velocity. Let's give it pressure. It's fine. Downwards. So Z negative minus 0.5 millimeter per second. It's fine. The bottom will be outlet here. Outlet. 0 pressure. Great. And I'll click and then click again and make this a wall. So you can also select this if it's more complicated. Initialize field 0, 0. This is the easiest. It will always work. Might be a bit slower, but for now it's good enough. In here, select how many cores you want. 4 is okay. Doesn't really matter. And press it. Press right case. And press run. We don't... Oh, because we changed boundary conditions. Yeah, we need to remesh it. Fine. And we can see all the commands here. If we ever get errors, we can copy this and then read what it says. Or we can just copy it into, I don't know, a ChatGPT or something, and it will usually tell us what's wrong if you don't know much about CFD. Now we can view the results. A second, and we get results. Great. We can slice it with a plane and a brush. Yeah, velocity. Okay. Yeah, it's ugly, but it's really small, so it's good enough. Yeah, we can see velocity. Great. So now that we checked that CfdOF is working, we close FreeCAD, and now we'll do SPH. So yeah, save it. Why not? We can close this. Now open FreeCAD as admin again, administrator. And now we want to go into Tools, Add-on Manager, and need to go into here, SPH. DesignSPHysics SPH. It's particle physics if you have a good GPU and for some specific things. And press install. Not successfully. Close it. And close it just in case. Now we need to open it again. So this SPH is launched in a bit of a weird way. Don't ask me. We go into customize. We go into macros. We click this list. And then we click this DesignSPH. Menu text, we can call it SPH, 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 SPH. And we need an icon. Because it's particles, I like balls. So select balls and press add. Now we go into toolbars. We click here general. Make a new toolbar, which is, we can call it YouTube toolbar. Let's call it YouTube, why not? Here, and then we search here for SPH, the particles that we gave it, and then we press this right arrow here, and then set our toolbar. Close this one. We right click, we say somewhere here should be the YouTube one. Where is it? Why is it not here? Give me a second. Toolbars? Global? Clip file, clipboard, workbench. Why is it not here? Okay, maybe let's restart it. Oh, okay, now it's here. Okay, I don't know. It's here. Okay. Now we click this SPH button, and this transforms our FreeCAD into the SPH one. We press setup plugin, and the weird thing about this is we need to set up libraries on our own, download them separately. I don't know why, but that's what needs to be done. So we go to DesignSPH GitHub, which basically we just do DesignSPH GitHub, and this is the link. Then we scroll down, and we go into here, option 2, download stable release. We go to this website here. We go the zip version here. We'll download. I think I downloaded it 5 minutes ago, so it should be fine. Oh no, whoops, I deleted it. Okay, so let's wait for it. Wait a second. While it's downloading, we can find where this is supposed to go. So we press %up data % to find where all the macros live, just like your Minecraft settings if you used to play. Now there is a folder called FreeCAD somewhere here. Where is it? Oh yeah, FreeCAD here. 1.1 mod, and then DesignSPHysics. Now we can open a second tab of Explorer. This thing downloaded. We can copy it here for now. And we can extract files here. Now the GitHub exactly says where you're supposed to put this. You're supposed to put this DualSPHysics folder into DesignSPHysics folder. So I think that's what we did. DesignSPHysics, DualSPHysics. Perfect. And now to check it, we open FreeCAD again. We open this funny SPH. We press setup plugin. And I think we just press OK and it will tell us if it's working. If you get no errors, that means it's working. So just a simple new case. Save it. Let's do it. New folder. Maybe let's put it desktop. Why not? SPH YouTube. And then YouTube. Also in here, you can try putting the ParaView executable here, but I think this window just resets every single time, so it's where is it? Yeah, I think it doesn't. I don't know. There's something wrong with it. Copy path. Yeah, if we paste it here, and then we open it again, yeah, it resets. I don't know. Maybe manually or something. But it's not a big deal, to be honest. And type. Yeah, this doesn't work. No, it resets. Yeah, that's fine. So SPH, it's particles, and it's only useful if you have a GPU, to be honest. You can argue about it, but unless you have a supercomputer, it's basically designed and made for the GPU. So we want to make the boundary, sort of a box where simulations run, a box of water, and we want to drop the box of water. So we make a box which will be our simulation area. We can make it, I don't know, 1 meter by 1 meter by 1 meter, let's say. And we press OK. Can we rename it? I think. And this will be box. We add it to SPH. It will be a bound. It will be a face. So only the faces are turned into particles. Now we want to add the second cube. This will be our water. This cube will be, let's say, 100 by 100 by 100. And we want to move it a bit higher from the ground. So let's say we give it 50, 50, 50. 50, 50, 50. So it's a bit off the ground. Press OK. And now add it to simulation. It will be a fluid. And it will be full. Now we press save. Make sure that the box is placed first. This is very important. Now water is second. Great. So we have our simulation. We want to define constants. You can take a look at gravity and if everything is going in a good direction. Execution parameters are quite important for us because in here, this is transient only. So we want to simulate 1.5 seconds and we want to save every 0.1 second to make it faster. Press OK. Save it. We want to, oops. We want to press GPU here to run on GPU. Now we want to generate case. It says we'll have 30,000 particles, which is in general running less than 100,000 is not worth it because GPU overhead will be too big and things will work weird. So in here we change the particle size so we can add in, let's say 0.5. This should make our particles bigger. Smaller, sorry. So there will be more of them. Save. GPU gen case. Now there should be 100,000. Okay, good. And now we can press run. We can open details. Here it just says that all the copyright. It's a tool. It can see my GPU here, somewhere in here, I think. CUDA cores or something. Let's wait for it to finish. And now it's running. So this for sure works on NVIDIA GPUs. I don't know about Radeon, but I doubt it. So just a recommendation, just download the latest NVIDIA drivers for it and it will work. You can hear that my GPU is detected properly somewhere here. Wait, can make it a bit bigger. Yeah, it detects my GPU properly. It can see the compute capability, which is good. Correct 32 gigs of memory. And then somewhere in here, you can see how many CUDA cores it has. It should be like 21,000 something, I think. Or not. Well, anyway, it doesn't matter. And it ran for 1.5 seconds. Now we close. Now in order to get the data out, we press part VTK. If our ParaView wanted to save, we could open it directly, but we just press export. It exported. Now we can open our ParaView separately. And we can open this case. So I think it was a desktop. It was YouTube something. YouTube. We want to into part. We open this series. Press apply. Full screen it. And we can see our cube of water and our wall. Now, when we press run, the water will fall. Or, whoops, sorry, gravity is in another direction. This is our floor. And we can see that it falls and it goes on the floor. So it's working. Great. So this is a quick tutorial. I recommend trying Fluid Dynamics and especially SPH if you have a good GPU. Because for specific use cases, it can be quite useful. And if you have any questions, leave them in the comments. I'll leave all the commands in the comments and a couple tutorials that are worth looking at for both of the softwares.